Let's look at the Over 40 game, a children's arithmetic game, and let's implement it as a procedure in which the two players play each other randomly, and we will be using our 3D procedure approach. So Over 40 is a two-player game. Players choose a number between 1 and 10 inclusive, but they can't choose one that's already been chosen. They add it to the total. First player over 40 wins. So for instance, A chooses a number between 1 and 10. B chooses a different number, adds it to what A has. A chooses a different number, adds this to the total. And the player that takes the total over 40, can't be equal to 40, must be strictly over 40, is the winner. So let's suppose that player A chooses the 2, and then let's suppose player B chooses the 4. That means that we now take that and add it, so now the score is up to 6. Then player A chooses 10. Now we're up to 16. Player A chooses the 7, and now we're up to 41. And so A wins. Now here's another example. This is a loop table, and it's the same game, not the same choices, but notice we start with a score of 0, and this is what we have so far. Player A chose a 9, so that gets rid of the 9, and you can see in this list there is no 9. Player B chooses the 2, and so that removes the 2, and you can see there's no 2 in this list, and so on. And in this case it's to 36, A chooses the 7, and A wins. Ultimately our goal is to determine if either player A or B has an advantage in going first or not going first, respectively. Here's another loop table. And to do that, we're going to write a procedure that has no inputs. It's just going to randomly play the Over 40 game, return 1 if the first player wins, and say 0 if the second player wins. So we have to define the game. It's going to be called Over 40. It's going to have a variable called turn, which counts how many plays have been made. Then we're going to have the score, that's the current score in the game. Remaining, that's the list of numbers we have not yet selected. And choice, that's the number selected from remaining in this turn. Now, what Python are we going to have to use that we may not have already seen? Well, we've already seen the randint, but it's worth repeating that we'll be using randint to choose a random number between A and B. And pop. Pop is a method that removes an entry from a list. Now let's also notice that an odd turn corresponds to the first player. Player A plays first, B is second, A is third, B is fourth, A is fifth, and you'll notice A is always on the odd turn. Let's look at an example with a loop table. And it's the same one that we saw again, but this time let's think of this with an eye of writing a procedure. So the first thing we should probably notice is that we're going to have a loop. So as we go down through here, through the loop, we're going to alternate between A and B, but notice that corresponds, A is odd, and B is even. We're going to randomly make a choice, add that to the score, randomly make a choice, add to the score, and we're going to do that as long as, or while, the score is below 40. Once it exceeds that, we end the loop and determine the winner. Going back to our design, we see from this loop table example a flow of information. We start out with the initialized variables, 0 for the turn, 0 score, and all 10 numbers remaining. Now, while the score is less than or equal to 40, we want to keep playing the game. we randomly pop a letter out of what's remaining, add to the current score. Once we have gotten past 40, then we're going to see if we have an odd turn or an even turn. If it's odd, we're going to return 1 and say that player A was the winner, 0 otherwise. Now we also need a document string, and here's exactly what our over 40 procedure is going to do. And here's our procedure. Notice that we are initializing while the score is less than or equal to 40, so we're using a while loop here, and this set of things is inside the while loop. We increase turns by 1. We choose an index. Notice here's our randint. It's going from 0 to however many are remaining, so it's going to choose an index for one of these, and then if we look at the documentation for pop, it's going to remove this indexed entry from what's remaining. That's going to be our choice. We update the score with our choice. Here we see if turns is odd or even. If it's odd, we say the winner's 1, else the winner's 0, and there you have it.